In this lesson, we're going to start talking about roots and radical expressions and how to solve them. So I want you to take a second, pause the video, and take your notes. So let's talk about taking the nth root of a number. In Chapter 4, you learned that if you raised a number or a variable to a power and it equaled a number, you would have to take the square root, because we dealt with raising x to the second power. You would use the square root property and take the square root of both sides to solve this. Well, you can do the same thing for any power here, but instead of taking a square root, you would take the nth root. So in order to solve an expression like this, we would take the nth root of a to the n, and we would take the nth root of b, okay? And this n and this n would cancel out. Your root would disappear, and you would get a equals the nth root of b, okay? So let's talk about how many answers you actually get. Depending on this number right here, it depends on how many answers you will get when you take a root of an equation. An odd number here will give you only one answer, one real answer. But if that number here is an even root, you remember back in Chapter 4 when we took the square root of a number, we got two answers. We got both a positive and a negative answer. So you need to be careful. You need to pay attention to whether you're taking an even root or an odd root. An odd root, again, gives you one answer. An even root gives you two answers, both a positive and a negative answer. The positive answer is represented as the nth root of b, and it's called the principal root. Okay, so any of your positive answers, when you take a root, it's called the principal root. So if you see something like this written in the book, they're only asking you for the positive answer to this. The negative root is the opposite of the principal root, and it's written with a negative sign in front. So if you see something that looks like this in the book, they're asking you for the negative root or the opposite of the principal root. So let's go ahead and do a couple of odd root examples. The first one is to find the real cube roots of the following numbers. So if we're going to find the cube root, we're going to need to take the cube root of each of these numbers. We'll put a cube root over it. In order to find the cube root, we're looking for groups of 3. Your index tells you the number that needs to be in your group for you to pull things out. When you were doing square roots, you looked for groups of 2, and you pulled out one of each of those groups. Here we're going to be looking for groups of 3. So we're going to go ahead and factor our number here, and we know that 500 factors into 5 and 100, and we're going to build our factor tree until all of our leaves are prime numbers. So 10 factors into 5 times 2. So if we take a look at all of our leaves, we have 5, 5, 2, 5, and 2. We actually have a group of 3. We have 3 5s here. So we're going to pull one of those 5s out. But now we don't have any more groups of 3. So whatever that we haven't circled, we are going to keep that underneath our radical sign. So 2 times 2 is 4. The answer to this problem, the cube root of 500, is 5 cube root of 4. Now let's take a look at how we would take the cube root of a negative number. The first thing we're going to do is we're going to put our cube root symbol over. But instead of factoring a negative 567, I'm going to say build your factor tree using your positive number. So what goes into 567? I know that 3 goes into 567. And it goes in there, let's see, 3 goes into 5 one time with 2 remaining. 3 goes into 26 8 times with 2 remaining. 3 goes into 27 9 times. I also know that 3 goes into 189. So how many times does it go into? 3 goes into 18 6 times, and it goes into 9 3 times. Okay, well again, 3 goes into 63 as well. So, oops, of course I wrote a 2. 3 goes into 6. 3 goes into 6 2 times, and 3 goes into 3 1 time. We're still not done. 21 is not prime, so we're going to factor this into 3 and 7, and now all of our numbers that are at the bottom, our leaves here, are all prime. We are looking for groups of 3, so we have 3 3s. I'm going to circle them. I will pull one of those 3s out, but now I have 2 numbers that are left at the bottom. And they do not belong to a group of 3, so they have to remain under our cube root as 21. So the answer to this is 3 cube root of 21, but because we had a negative number that we were taking a cube root of, our answer will be negative. So how do you take the cube root of a fraction? Well, we are going to first put our cube root over. The way that we do a problem like this is that we take the cube root of the top number and we divide it by the cube root of the bottom number. And instead of building my factor tree, I already know what the cube root of 8 is. It is 2. And I know what the cube root of 27 is. It's 3. And because I had a negative sign underneath here, my answer is going to be negative. So it's negative 2/3. Now let's take a look at finding the 5th root of a number. So the first thing we're going to do is put a 5th root over our number, and we're going to factor. And we notice that this number ends in a 5, so we're going to factor a 5 out. 5 goes into 31 6 times with 1 remaining. 5 goes into 12 2 times with 2 remaining. 5 goes into 25 5 times. All right, so 625 is not prime. I know 5 goes into it because it ends in 5. 5 goes into 6 1 time with 1 remaining. 5 goes into 12 2 times with 2 remaining. 5 goes into 25 5 times with nothing remaining. I know that 5 goes into 125 25 times, and I know that 5 goes into 25 twice. So now we're taking a 5th root. Instead of looking for groups of 3, we're looking for groups of 5. And how many 5s do we have? 1, 2, 3, 4, 5. We have 5 5s. The answer to this problem, we will pull one of those 5s out of the group, bring it outside of our radical. The answer to this problem is 5 because we don't have anything left, no numbers left that need to go under our 5th root. So the answer to this problem is 5.